So to graph means to plot enough points until you see a pattern. So I'm going to try that for this equation. So I have y equals negative 3x squared plus 3. So I need to pick some x values to plug in and calculate the y values. So anytime it's y equals, we pick some x's. Let's try this set here. And the ones you choose kind of depend. This might be good, this might not. So let's see, if I plug in negative 2 here, I should use parentheses. So we square that, plus 3. And you could whip out a calculator to do that calculation if you want. So negative 2 squared is 4, times negative 3 is negative 12, plus 3 gives me negative 9. Plug in negative 1. Negative 1 squared is 1. 1 times negative 3 is negative 3, plus 3 gives me 0. Plug in 0. Zero squared is 0, times negative 3 is still 0, plus 3 is 3. Oops, positive 1, plus 3. 1 squared is 1, times negative 3 is negative 3. Negative 3 plus 3 is 0, which we've seen before. Interesting. Plug in 2. 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 plus 3 is negative 9. So it is interesting that we have some points that mirror each other. Negative 2 and 2 have the same value. Negative 1 and 1 have the same y value, with that 0, 3 in the middle. So we'll plot those points now. So let's see, negative 9 is kind of off my chart. I'm guessing it would be somewhere down here-ish. And then negative 1, 0. So go over to negative 1. The 0 says don't go up or down. And then I have 0, 3 as a point. So 0, it'll go left or right, up to 3, 1, 0. And 2, negative 9 is going to be somewhere down here-ish. And so I think I see a pattern here. If I'm not sure how the pattern works, I could always plug in another number. Like I could even go fraction here. I could try plugging in 1/2 to see what happens. See if I perceive the pattern correctly. And this I think I'll write a little bit more down. 1/2 squared is 1/4. 1/4 times negative 3 is negative 3/4. And then we have to add 3 to that. So 3 minus 3/4 would be 2 and 1/4. So x equals 1/2, and then 2 and 1/4. Yeah, that fits in with the pattern I was seeing here. From this appears to be the top, and then it drops down this way, and it plunges downward steeply. And pretty much a similar thing is going to happen on this side. So I plotted enough points till I saw the pattern, and sometimes it depends on the day. Sometimes 3 points is good, sometimes 5 is good, sometimes 6, sometimes more. That's why we have graphing calculators, because this is complicated. Finding that pattern is what we're trying to do. Some interesting things to note: when you square a number, if you square a negative or a positive, you get the same result, because the square kind of kills the negative. Negative times a negative is a positive. So that's one reason when we have a square in an equation, we get this turning point here. And it could go the other way. It could come down and turn upward. So this is called a parabola. And the equation that goes with the parabola is called a quadratic. Oops, it's supposed to be a cube. All right, so let's try that in the online graphing utility here. So filling in the table and then plotting the points. So to plot here, I have to either decide, is this a line? Is it a quadratic, or is it one of those exponential curvy things? Looks more like a hockey stick. So I'm pretty sure it's this one right here, the parabola. And the way the parabola tool works is I need to pick 2 points. One of those points needs to be that turning point. And you always do the turning point first. So I discovered the turning point was right here. And then I got to pick another point. So I believe I had 1, 0 was the other point. And I could go either way. If you decide you misplaced a point, you can move that point to wherever you need it to be. And the same thing with the turning point. If you put that in the wrong spot, you can pick it up and move it anywhere you want. So it's possible that you could adjust your parabola. All right, pretty sure that's the right one. All right, that's it for now. Do good math. I'll see you in the future.